Here is the first problem from our rotational kinematics and torque problem set. We have a gyroscope initially spinning at an angular velocity of 32 radians per second, and it slows at a rate of 0.7 rads per second squared. This is an example of motion with constant angular acceleration. So we have motion with constant angular acceleration. Okay, let's write down what we know. Okay, we know initially the gyroscope is spinning with an angular speed of 32.0 radians per second, and it comes to a stop. So its final velocity, or angular velocity, is 0 rads per second. We also know it has constant angular acceleration, and since it's slowing down, the angular acceleration should be negative, and it is negative 0.700 radians per second squared. So question A is we are asked to find how many revolutions it makes before it stops. We're going to consider its initial position at time equals 0. Its initial angle, rather, is 0 rads. And we want to find the final angle. Okay. So the thing to note with this is that our kinematics equations for 1 and 2 dimensional kinematics apply for rotational kinematics. So recall that we can relate velocity to time and acceleration. So the final angular velocity is equal to the initial plus the angular acceleration times our time. Now we know everything here except for time. So let's solve for time. So time is the change in omega over alpha. So our change in omega, remember we go from a rate of 32 radians per second to 0. So our change in our angular velocity is negative 32.0 radians per second, and our acceleration, of course, is the negative 0.700 radians per second squared. Note that our radians cancel. This second in the numerator cancels with one of the seconds in the denominator, and plugging all of that into your calculator, you should find that delta t is what is it? It's I don't remember. Hold on, let me calculate it. So 32 divided by 0.7, 45.7 seconds. Good. Okay. Now, how do we find the angle? Well, we can use the following equation. Our final angle is equal to our initial angle plus our initial speed times delta t plus 1/2 times our acceleration times delta t squared. Okay, so our final angle is just equal to 0. Well, we're just plugging in all of our numbers. 32 rads per second times our time, which is 45.7 seconds, plus 1/2 negative 0.7 rads per second squared times 45.7 seconds squared. Great. We know everything here. This is a calculator problem. You can compute the final angle to be 731.4 radians. Okay, well that's the angle. What we were asked to find is how many revolutions that this gyroscope makes. So to figure that out, we need to do the following. The number of revolutions is equal to our change in angle over the amount of radians for one revolution, which is just 2 pi. So our change in angle, if we go from 0 to 731 rads, is just the 731.4 rads, and we divide by 2 pi radians, and we should get 116 is our number of revolutions. We could have done this a slightly different way. Remember the equation, we have motion with constant acceleration. We could have used the equation, our final angular velocity squared is equal to our initial velocity squared plus 2 times the acceleration times the change in angle. And you could have solved for that delta theta right away, and then do the calculation we just did above. So that's the answer to our first question. Let's look at it in this view here.